Welcome to Technical Mentors MATLAB series. We are working on design filter in MATLAB. As we have discussed in the previous video, how we can use ECG data in the MATLAB to get filter. And in the second video, we did we create a my filter function. In the third video, I design and implement a high filter design to remove a DC drift and noise using Hanning technique. If you want to watch and know how and you want to learn everything about fair design, please see the previous video and then come to this video. This video is about applying Hamming technique. Hamming function is also built-in function in the MATLAB. Hamming function, we use Hamming function to remove DC drift and 50 Hz noise. Okay, so applying DC drift, this was the section of Hamming technique, and now we are using Hamming technique. So we apply Hamming technique, create a figure, and Hamming is the variable to use Hamming techniques. And Hamming, we create variable using Hamming technique. HN2 is a variable we designed by shuffling. Okay, by shuffling. So we design a apply Hamming. This is Hamming function. You can see function detail in the MATLAB, or you can see open Hamming. This is Hamming function and the MATLAB button function. You can see how it is work. So we apply Hamming technique. After the Hamming technique, we do a Fourier transform for high pass filter. So we apply this, plot this Fourier transform in the MATLAB. And then what is so we do this. So I think this is Wamming technique. So we labeling all the data. This is x limit 0 say 0 to 100. So we see the graph. This is a frequency response using the Hamming tech window. This magnitude and dB in y-axis and frequency in hertz and x-axis. Create second function, second figure, and we create time domain using Hamming window technique. So we create a variable filter uh, as an initial variable zeros, and from one is variable length mean. Its column should be length of Wamming this, and row should be 1. So we create this variable. You can see where is filter variable. This is filter variable. You can see column are 100 1000 and row is 1. Okay, so we apply Wamming. output from. So we use my filter design that we designed in the second step. So this is function. You can, if you want to watch how it function work, please see my previous video. Okay, so we apply warming technique. Okay, and create warming output and plot Hamming with respect to time. So you can see this is graph, and we label this graph time domain using Hamming window, amplitude and millisecond, time in millisecond, amplitude in millivolt. Now create third figure, Weighing output and use Fourier transform. Okay, we see the output after filter in this section. So we create output using Fourier transform. Okay, we created and plot Hamming technique after filter, and after this, we limit the x limit on. Okay, you can see x limit is 0 to 110. So and label. So this was our uh, output after filter design, after filter Fourier transform using. So this was our Hamming technique to use high filter to remove DC drift and noise of 50 hertz. Okay, thank you so much for watching this video.